Off the coast of your favorite beach, under the water, there's an entire ancient world. It's just forgotten. These submerged ruins, they're everywhere. A global phenomenon. They're the drowned skeletons of civilizations that used to dominate their time, and then they just vanished, suddenly. It's one of the most compelling mysteries we have. Our shared past. By the end of this, you'll have a new lens, a way to look at history that connects geological fingerprints to legendary floods. We're going to uncover why these cities were built right in harm's way, and what specific forces actually dragged them under the sea. What story does a stone column tell when it's covered in coral now? The answers, they change how you see the fragility of any society. What do you think is the greatest threat to a city that's thriving? A diver moves over a stone column. It's covered in coral now, in sea fans. This isn't a shipwreck. It's a piece of a street, a fragment of a marketplace. It's from a city that used to be in the open air. These are coastal ruins. They're scattered across the planet. Like pages torn from a history book, sunken harbors in ancient Greece, submerged temples off India, drowned villages in the North Sea, lost ports in the Americas. They form a silent network. Archaeologists call them sunken archives. Each one is a time capsule. It preserves a single, catastrophic moment with heartbreaking clarity. Geologist Emily Carter says the detail is stunning. A pot left on a floor, a wall that fell in one direction, the layout of a city block, all frozen in time by the sea. That sets them apart. An inland city might get buried slowly, under dust or reclaimed by forest over centuries, but a coastal ruin tells a swifter story. A more decisive one. It speaks of a direct confrontation between human civilization and the power of the water. These weren't remote outposts, they were vital hubs. Ports humming with trade, temples where communities gathered, entire urban districts built with confidence, right at the water's edge. Their location was their lifeblood. It connected them to the world, and that same location became the key to understanding their disappearance. Why would so many cultures across millennia and continents make the same choice? The same seemingly risky choice. To answer that, you have to listen to what these sunken archives are whispering. They're not just random stones, they're deliberate markers, pointing to a pattern of change, a change so immense it reshaped the very edges of our continents. Pavlopetri, off the coast of Greece. Its stone streets are underwater now, about 5 meters down, and you can still see the neighborhoods. This was a port 1,000 years before the Parthenon. They built there on purpose. The sea was a highway. It connected them to other places, to goods, long before land routes were safe. It was a food source, fish, shellfish. It could support a lot of people, and it was a kind of wall, a coastline for defense with the water as a barrier or a way out if you needed it. That was the logic. Control the harbor and you control the region's wealth. You see it everywhere. Phoenician traders, the ports of the Indus Valley. Prosperity started at the docks, but that strategy had a flaw, a fundamental one. These cities were a bet, a wager that the shore would stay where it was, that the sea would be predictable. They built their walls, their temples, monuments to their own confidence, on the one thing they couldn't control, the ground. The key is in the geology. That's how you separate the legend from the actual event. There's a sonar image from off the coast of India. It shows a grid. Streets, a layout that's too perfect to be natural. That's what people connect to Dwarka, the city from the old texts. But the real story isn't the shape. It's in the dirt, the sand and silt covering those streets. When you look at the sediment layers on the seafloor there, you don't see a gentle change. You don't see a slow, gradual rise of water. You see a violent break, a single, clear line in the earth. Below that line, it's the soil of the land, ancient pollen. Charcoal from fires, the packed earth of a road, then suddenly that layer stops. Above it is a thick deposit of marine sand, shells, debris carried by the sea. That's the geological signature of a sudden drowning. It's the difference between a pond filling slowly with rain and a wave crashing over a wall. The evidence is even stronger under the water. They find buildings that collapsed in place, walls that fell in one direction like they were pushed by a single, tremendous force. They find wooden posts. The bases of structures still standing upright where they were driven into the ground. That's crucial. If the sea had risen slowly over decades or centuries, those wooden posts would have rotted away long before the water covered them completely. Their preservation is a stopwatch. It means the water arrived fast, too fast for decay to begin. The same logic applies to stores of grain or other organic material found in these ruins. They're snapshots, a city interrupted, a marketplace flooded before the goods could be removed. These aren't just ruins, they're crime scenes, and the geological evidence is the testimony. It points to a rapid, catastrophic influx of water. A tsunami from an undersea earthquake, maybe, or a massive storm surge from a powerful cyclone. This challenges the older, quieter theories. The idea that these cities were peacefully abandoned as the climate changed slowly. The stones and the sediment tell a different story, a more dramatic one. A thriving community one day and a sunken archive the next. So if the water arrived with that kind of force, what could trigger an event on that scale? Something capable of drowning not just one city, but many in different parts of the world. The force involved is almost impossible to grasp, but we have a modern example. December 26, 2004, a huge earthquake under the sea near Sumatra. The energy it released was immense. It pushed the seafloor up. That movement displaced the water, and that created waves, tsunamis. They spread across the Indian Ocean, moving as fast as a passenger jet. When they hit the coast, they didn't look like ordinary waves. They were walls of water, in some areas over 30 meters tall. They pushed kilometers inland. Whole towns were wiped away in minutes. The destruction was total. That event, a tragedy from our own time, gives us a kind of model, a way to understand what might have happened to those old coastal cities. A tsunami fits. It matches the geological evidence exactly. The sudden, violent deposit of ocean sand over a city layer. Buildings knocked over all in one direction, like a giant hand pushed them. Huge boulders scattered far inland from the shore that no ordinary storm could have moved. That's the signature. Take the ancient port of Caesarea Maritima, built by Herod. It was an engineering wonder of the Roman era. Its artificial harbor was one of the biggest ever made, but core samples from its ruins tell a different story. Researchers found a clear layer of open sea sediment and debris. Pieces of pottery and building material, all broken and mixed together. This layer sits right on top of the harbor's original floor. It points to a sudden, violent flood, probably a tsunami. It would have broken through the famous breakwaters and scoured the port clean. The city lived on, but its economic core, its reason for existing, was destroyed in a day. Then there's the Minoan civilization on Crete. Their culture, centered on palaces like Knossos, seems to disappear around 1600 BCE. For a long time, the main theory was a giant volcanic eruption on Thera, modern Santorini. The eruption itself would have been catastrophic, but the real killer for the Minoan coastal towns might have been what followed. The partial collapse of the volcano into the sea would have set off a tsunami of unbelievable size. Computer models show waves over 40 meters high hitting Crete's north coast in minutes. They would have smashed into the Minoan ports and villas, not just flooding them, but tearing them apart. Saltwater would have rushed inland, poisoning the farmland that fed everyone. In a few hours, a society built on sea trade and agriculture could have had its foundations washed away. The wave was the immediate disaster, but the aftermath, the lost crops, the destroyed ships, the broken trade networks, that was the slow, certain end. One day rewriting a civilization's fate, that's the terrifying efficiency. It doesn't just flood a city, it takes apart the very systems that let a city function. The water goes back, but the world it leaves is completely changed. So if a tsunami is such a perfect fit, why isn't it the answer for every sunken city? The answer is a slower, more gradual process, one that doesn't shatter cities in an instant but lets them sink, bit by bit, into a waiting grave. A tsunami is a sudden, brutal event. But there's another force, a quieter one. It doesn't arrive as a wave, it's a creeping, relentless advance. You can walk along the harbor in Alexandria, Egypt. Look down into that clear, turquoise water. You can see them there, the foundations of Cleopatra's palace, the legendary lighthouse, an entire royal quarter. All of it resting on the seafloor, as if the city just lowered itself into the Mediterranean. This wasn't a single catastrophe. It was a slow surrender. And it comes down to two words: relative sea level rise. It's not just the ocean getting higher, it's the land getting lower, or both happening together. Think of sitting in a boat that's slowly filling with water. You could be bailing it out, but if the boat itself is also sinking, your fight is doomed from the start. That's what happened to so many ancient coastlines. There's a global process, eustatic sea level change. When the last great ice age ended, ice sheets miles thick began to melt. All that water had been locked away on land. As it returned to the oceans, the sea level rose globally, over 100 meters. That's the water filling the boat. But then there's the local process, isostatic adjustment. Imagine a giant memory foam mattress. You press down on one spot with your hand. That's the weight of a continental ice sheet. The land underneath sinks, then you lift your hand, the ice melts. That spot slowly rebounds, it rises back up, but here's the crucial part. The land far away from the ice, like the coasts of the Mediterranean, reacts differently. It's like the edges of that memory foam. When you press the center down, the edges bulge up a little. When you release the center and it pops back, the edges sink down. So for a city built on a coastal bulge, the end of the ice age meant a double disaster. The global sea was rising, and their local coastline was sinking. The relative change was accelerated. This is the insidious threat. It doesn't destroy in a day. It works over generations. A seawall that held for a grandfather is constantly being reinforced by the father. The son watches the family's freshwater well just inland turn brackish, undrinkable. As saltwater seeps into the aquifer, the harbor, once deep and safe, becomes a silted-up lagoon. Useless farmland near the shore becomes a salt marsh. Its crops fail. The economic and social cost is relentless. Every year, more resources go into holding back the water. More energy is spent on survival than on growth, on art, on culture. It's a slow-motion collapse, a demoralizing retreat, foot by foot, street by street. Until the original heart of the city is abandoned to the waves, the community doesn't shatter, it fragments, it disperses inland, losing its cohesion. Its shared identity tied to that specific place by the sea. That's what the stones of Alexandria whisper. They tell of a grandeur that didn't fall, but that gradually, quietly, sank beneath its own weight and the changing bones of the earth. So we have these two powerful forces, the sudden violence of the wave and the patient, grinding pressure of the rising sea. But could there be a third actor? One that didn't just drown these cities from the outside, but made them collapse from within, made them vulnerable in the first place. The water's final victory wasn't just covering the land. It was poisoning it. Long before a street flooded, something else could start. A farmer walks to the family well at dawn. He draws a bucket, drinks, and stops. The taste is wrong, salty, metallic. The freshwater spring that sustained his grandparents is now tainted by the sea. That's saltwater intrusion, a silent, creeping disaster. It happens as the sea level rises, pushing its dense, salty water inland underground into the porous aquifers that hold a region's freshwater, and once that happens, it's almost impossible to reverse. The consequences are profound. First, the drinking water is gone. Communities have to travel farther or rely on precarious rainwater. But the second effect is even more devastating for a civilization. It attacks the food supply. When salt water seeps into the soil or when farmers use brackish water for irrigation, the land turns against them. Salt accumulates in the earth. Most crops we rely on, like wheat or barley, can't tolerate it. Their growth is stunted, yields plummet. Over a few growing seasons, a fertile coastal plain can become a cracked, white-crusted wasteland. There's a historical parallel far from the coast that shows how destructive this can be. The ancient empires of Mesopotamia, in what's now Iraq, were masters of irrigation. They built canals to bring water from the Tigris and Euphrates to their fields. It made the desert bloom, but over centuries a flaw emerged. The irrigation water under the hot sun would evaporate. It left behind dissolved salts which slowly built up in the soil. Cuneiform tablets tell the story. They record a staggering decline in crop yields. One text notes a field's harvest had fallen to just 1/3 of what it was a generation before. The land was exhausted. Salt had stolen its fertility. That agricultural collapse weakened the economic foundation of entire city-states. Now translate that to a coastal city. Instead of salt accumulating slowly from irrigation, imagine the sea itself delivering it directly into the water table and the soil. The effect is the same, but it can happen much faster. A community might withstand a terrible storm. They could rebuild shattered walls, but how do you rebuild a farm? How do you reclaim soil that's turned to salt? You can't. This creates a slow burn crisis. Food becomes scarce and expensive. Hunger spreads. The economy, often based on farming and trade, withers. People begin to leave. Social bonds fray under the stress of scarcity. What remains is a hollowed-out society, a population weakened by malnutrition, a government straining under the cost of constant adaptation, a community that's lost its resilience. This is the silent killer. It doesn't make for epic legends of a single, catastrophic wave. It's the story of 1,000 small failures, 1,000 hungry seasons. It prepares the stage for a final act. When the next major storm surge arrives, it doesn't strike a thriving, resilient city. It hits a place already on its knees, a society that spent all its strength just trying to hold back the salt. The wave then becomes less of a cause and more of a conclusion. So you see the full threat, the sudden violence of the geological event, the patient, rising pressure of the sea, and this internal decay, this poisoning of the very source of life. But if these collapses were so total, how do we know about them at all? Why do their stories, however fragmented, still reach us? The answer lies not in the stone they left behind, but in the stories they told about why it sank. The stones and the soil tell one story, but humanity tells another. There's a shared memory scattered across the globe in cultures that never met, a memory of water. From Noah's Ark in the Hebrew tradition to the mats of the sage Manu in ancient India, stories of a great, world-covering flood are everywhere. In the Epic of Gilgamesh from Mesopotamia, where the gods decide to wipe out mankind with a deluge. Echoes in Plato's account of Atlantis, an island civilization swallowed by the sea in a single day. Even in the Aboriginal Dreamtime stories of Australia, tales of the coastline changing forever. Ancestral lands lost beneath the waves, these aren't coincidences. They feel too specific, too visceral. What if they aren't fiction but a form of long-term testimony? Cultural memories of real, catastrophic events passed down over hundreds of generations. The trauma of watching your entire world disappear under the water. That would be seared into a community's identity. How would you explain such a thing to your children and to their children? You would build a story around it. A myth to contain the unimaginable, and when we listen now, the details are startlingly consistent. They almost always include a divine warning or an omen. A chance for a select few to prepare, then the sudden, overwhelming inundation. The water rises from below and falls from above. It covers the highest mountains. And finally, the few survivors floating on a vessel carrying the seeds of a new world. This narrative pattern mirrors the geological evidence at submerged sites. The sudden, catastrophic deposit, the feeling of a world-ending event, the few artifacts that survive, like the seeds on the ark, to tell the tale. Take the Mesopotamian flood story, one of the oldest written narratives we have. It describes a storm so fierce it terrified even the gods. The tablet reads, "For 6 days and 7 nights the wind and flood came. When the 7th day arrived, the flood, which had fought like an army, subsided in its onslaught." This isn't a seasonal river flood. This is the language of oceanic fury, of a tsunami's relentless assault and then its retreat. Plato's Atlantis, while likely a philosophical allegory, is rooted in a real geological context for the Greeks. They were a coastal people who knew the terror of earthquakes and tsunamis in the Aegean Sea, the story of a sophisticated island empire vanishing without a trace. That would resonate with a culture that had seen ports shattered by the sea. These myths served a crucial purpose. They were the oral history of pre-literate societies. A way to encode a vital survival lesson. Do not build your cities too proudly upon the shore. The sea can take everything. They preserved the trauma, but also the lesson across millennia. And this gives us a unique lens. When we triangulate the data, the physical ruins on the seafloor, the geological signature in the sediment, and the enduring echo in global mythology, a picture comes into focus. It suggests these weren't isolated tragedies. They were formative events in human history, experiences so profound they shaped our oldest stories about the world, about the gods, and about our own fragile place upon the land. Beneath the Gulf of Cambay, off India's coast, the sonar maps show a grid, straight lines, right angles, a pattern that doesn't occur in nature. This is the place linked to the Legend of Dwarka. The Golden City, ruled by Krishna. For centuries it was just a story, a city of gems and silver gates, said to have sunk when Krishna left. Then archaeologists started diving. What they found in the silt wasn't myth. It was stone, pottery, evidence of an ancient port. They've brought up stone anchors, huge ones for large ships. They've found pottery pieces, some whole, dating to around 3,000–4,000 years ago. That's the traditional time for the Krishna stories, and then there are the structures. Divers have mapped what look like foundations, massive walls, large blocks fitted together, outlining what could have been a fortified perimeter. The layout suggests planning. A settlement built with purpose, facing the ocean. This evidence does something. It anchors the legend. The stories talk about wealth, trade, a maritime kingdom. The stone anchors, the scale of the foundations, they support that. They point to a place engaged with the sea, a hub. But the archaeology raises a harder question. How did a place built this solidly end up under 10 meters of water? Geological studies of the region show a landscape in flux. Core samples from the seabed tell a clear story. There's a layer with terrestrial material, river silt, freshwater plant traces, charcoal from human habitation. Then, abruptly, that layer is capped by a thick deposit of marine sand, full of seashells, ocean debris. That's the signature of a rapid drowning. The city didn't sink slowly, it was inundated. Quickly, the leading theories point to two forces maybe working together. One involves the Sarasvati River. Ancient texts describe a mighty river flowing to the sea. Geological surveys suggest this river, fed by Himalayan glaciers, may have shifted course or dried up due to tectonic movements. That kind of shift could destabilize the coast. cause the land to subside. The second force, maybe the final blow, could have been a tsunami. The Gulf of Cambay is seismically active. An undersea earthquake could generate a wave, funnel its energy into the Gulf, right onto the low-lying city. The force would be catastrophic, scouring buildings from their foundations, depositing that thick layer of ocean sand over everything. The story of Dwarka is where archaeology and myth have a conversation. The legend gives the event meaning, a narrative of divine purpose, an era's end. The stones and sediment give it a timeline, a mechanism, a tragic intersection of human ambition and planetary force. Together, they tell us a thriving metropolis, a center of its world, can vanish, leaving behind whispers in stories and a silent, geometric grid on the seafloor waiting to be read. The story of a city ending, it's never just the water coming up. It's the world changing around it. Think of Petra, that inland city carved from red cliffs. Its decline wasn't about the sea, but it was about water. They had channels and cisterns, a whole system to catch every drop of rain in the desert. But then the regional climate shifted. The rains became less reliable. And that entire system was stressed. The city's greatness was tied to its control of water. When that control failed, its power faded. That same logic applies to coastal megacities with even more force. They weren't just fighting the sea, they were at the mercy of the whole sky. This moves us past simple sea level rise into climate oscillations. These are long-term, natural shifts in weather patterns that can last centuries. Like the medieval warm period from about 900 to 1300 CE, unusually mild temperatures in the North Atlantic, or further back, the 4.2 kiloyear event. Around 4,200 years ago, evidence from ice cores and lake beds shows a sudden, severe shift to drier conditions across the planet, from the Mediterranean to Asia. These weren't local droughts, they were planetary recalibrations. For a coastal city, a shift like that could unravel everything. First, it could alter the monsoon. Those seasonal rains that fill rivers and aquifers might weaken, or arrive in chaotic, destructive bursts instead of steady patterns. Less rain inland means the rivers carrying fertile silt to the coast run lower. That silt builds deltas, it counters erosion. Without it, the land shrinks and the sea comes closer. At the same time, a warmer ocean surface can fuel more intense storms. The cyclones or hurricanes could become less frequent but far more powerful. So you have this cumulative stress. A city is already dealing with salt poisoning its wells and fields. The sea is gradually rising, claiming land, and then the climate backdrop shifts. The rains that should dilute the salt and fill the reservoirs fail. The rivers bringing new soil run dry, and when the storms do come, they arrive with unprecedented fury. This is the holistic view of collapse. It's not one disaster, but a cascade. A major port might survive a direct hit from a powerful cyclone, even if it's battered. But if that cyclone is followed by 3 years of drought, the damage becomes permanent. The workforce is hungry, rebuilding stalls, trade partners look elsewhere. The social contract, the shared belief in the city's future, begins to crack. The political and economic systems buckle under the cost of constant response. What you get is a systemic failure. The city's ability to adapt is exhausted. Its resilience is gone. So when the next major flood surge arrives from a storm or a tsunami, it doesn't destroy a functioning society. It just administers the final blow to a patient already in decline. The water covers the city, yes, but the collapse was already underway in the empty granaries, the abandoned neighborhoods, the lost hope. That changes the question. It's not what drowned these places, it's what made them so vulnerable in the first place. The ruins show the fight, not just what was lost, but how people pushed back. At Palecastro, on Crete's eastern coast, there's a seawall made from huge limestone blocks. It wasn't for armies, it was built against the sea. This wall, over 3 meters thick in parts. It tells a story of adaptation, A community saw the threat and gathered its resources to hold the line. They weren't passive, they were engineers in a long contest. You see these adaptations. The Phoenicians at Tyre built breakwaters out into the Mediterranean to calm their harbors. In the Indus Valley at Dolavera, they built systems. Dams, canals, reservoirs to handle floods and droughts. The Romans made a concrete that could set underwater. They built ports in open seas. Each innovation is a data point. It tells us about the pressure they faced. A drainage channel means heavy rain sometimes, but a massive seawall like at Palicastro means a serious recurring threat. It hints at storm surges powerful enough to scour the coast. It means the community had already suffered losses. They invested huge collective labor to stop it happening again. The scale of the defense measures the fear. By studying these, you can chart the escalation. First, they might have raised their house foundations. When that wasn't enough, they built a barrier. When the barrier was breached, they made it taller, thicker, longer. It becomes an arms race, human ingenuity against the rising power of the ocean. The story turns from tragedy to something more complex. It becomes a testament to resilience, that stubborn refusal to surrender a home. For generations, even centuries, these adaptations could work. They provided security. They let a city thrive in a precarious place, but the ruins are underwater. That fact announces the final outcome. There's a tipping point, a moment when the environmental force exceeds the design of the society trying to contain it. Maybe a storm more powerful than any in memory, a tsunami higher than the wall, or the slow creep of sea level rise which no wall can stop forever. The ocean would eventually seep underneath or rise above any static defense. The ancient engineering solutions were monumental but static. They couldn't adapt to a rapidly changing baseline. They were a colossal investment in preserving the status quo. And when the status quo itself began to shift, the sea level, the coast, those investments became obsolete. The massive blocks of the Palicastro seawall are now tumbled and scattered. Some on the beach, others just offshore under the waves, a monument to a battle that was, in the long arc of time, unwinnable with the tools they had. That's the sobering lesson. In stone and water, it shows resilience has boundaries. A society can be clever, resourceful, determined. It can build wonders to protect itself. But if the environmental pressures escalate beyond a critical threshold, even the greatest adaptations will fail. The ruins ask a difficult question. Where is that threshold for us? With all our technology, are we building taller seawalls against a rising tide? Or are we addressing the forces causing the tide to rise? The ancient coastlines hold the answer to what happens when the fight is only defensive and the world keeps changing. A single ship loaded with copper never made it to port. And that one failure, could ripple across continents, because the ancient world, it thrived on connections, a whole web of maritime trade, linking empires from the Aegean all the way to the Indus Valley. These ships, they carried more than just goods. They carried ideas, they carried technologies, diplomatic messages, the very stability of the age. You had ports like Ugarit on the Syrian coast, or Troy guarding the Dardanelles. These weren't just cities, they were vital switches in a vast economic circuit. And when a switch is thrown, suddenly, the entire network goes dark. Think of a modern supply chain disruption, but with no alternative routes, none. By the late Bronze Age, around 1200 BCE, a complex interdependence had developed. Cyprus supplied the copper, Anatolia and Afghanistan supplied the tin. You combine them, you get bronze, the alloy for weapons, for tools, for status. Egypt sent gold and grain, the Levant sent purple dye and glass. This whole system, it required trust. It required established routes, safe harbors. A coastal megacity served as the warehouse, the customs house, the bank, and the repair dock. Its sudden loss was an economic earthquake. The ruins of a sunken port, they're more than a drowned city. They are a severed artery. and when that artery is cut, the effects travel upstream and downstream. First, the immediate region is starved of imported essentials, the tin for bronze making stops arriving, so suddenly armies cannot rearm. Farmers cannot replace broken plowshares. The scarcity makes the remaining metal, the existing stockpiles, astronomically expensive. Then the downstream effects hit the producers. The copper miners on Cyprus, they have no one to sell to. Their economy collapses. The specialized sailors, the merchants in that lost city, they're gone. And they take their knowledge with them, knowledge of currents, of languages, of long-standing trade agreements. That loss of institutional memory, it's catastrophic. It can take generations to rebuild. This creates a domino effect. A civilization like the Hittites, inland, dependent on coastal allies for trade, might find its tin supply cut off. Its military advantage evaporates. Rivalries over the remaining resources, they intensify. Diplomatic ties, once maintained through gift exchanges those ports facilitated, they fray. And they snap. The result is a cascade of failures. What begins as an environmental disaster, a tsunami drowning Ugarit, becomes a geopolitical catastrophe. Trading partners, now isolated, turn inward. Long-distance travel becomes perilous as piracy rises in the unpatrolled seas. That shared cultural language of the era, seen in similar art and goods across great distances, it begins to fragment. We call the period that followed the late Bronze Age collapse a dark age, not because the sun went out, but because the lights of connection went off. One by one, the intricate system flickered and it failed. The archaeological record shows this clearly. In layers dated to this time, the beautiful, internationally styled pottery disappears. It's replaced by simpler, local designs. The flow of luxury goods ceases. Written correspondence between kings, found in archives like at Ugarit, shows desperate pleas for help. Pleas that apparently went unanswered. The network was already breaking down. This reveals a vulnerability, a profound vulnerability of interconnected societies. Their strength is also their fragility. A modern analogy might be a cyber attack on a global financial clearinghouse. The immediate target is paralyzed, but the shockwaves cause bank runs, market crashes, thousands of miles away. The ancient world had no backup servers. When a key port sank, taking its merchants, its ships, its treaties to the seafloor, it could erase a century of complex economic integration. The ruins are silent on the politics, but they shout the economic truth. Prosperity was built on a coast, and when that coast changed, it didn't just wash away stones. It dissolved the glue, the very glue holding distant civilizations together. So if the economy could shatter so completely, what happened to the people? The people who lived through it, where did they go when the waves receded and the trade ships stopped coming? The water off southern Laconia is so clear it feels like you're flying. And below you there's a city, Pavlopetri, spread out across the seafloor. It's a ghost map from the Bronze Age. The streets are still streets, courtyards are open spaces. Tombs are quiet chambers. This isn't just scattered ruins. It's the oldest known submerged city we have, a complete urban plan preserved in stone for 5,000 years. To walk its grid, even in your mind, is to step into a functioning community, a day that never ended. You can follow the main road. It's wide enough for carts. It leads you past the foundations of homes. Some are large with many rooms, others are more modest. Archaeologists have mapped distinct neighborhoods, which suggests a social structure. And the artifacts from the silt tell the story of daily life, not grand treasures, the humble, essential things, pottery for storage, for cooking, stone tools for grinding grain. Loom weights for weaving cloth. These objects whisper of domestic routines, meals prepared, clothes made, a community feeding and clothing itself. Then there are the pithoi. Those massive storage jars, finding them suggests surplus. a stable food supply, likely from farming the nearby plain and fishing the sea. The economy is written in the stones. One structure near the old shoreline is identified as possibly a warehouse or a customs house. Its location is key right at the water's edge for loading and unloading. This points to trade, to ships coming and going, connecting Pavlopetri to other ports across the Aegean. But the most poignant spaces are the tombs, cut into the bedrock on the city's outskirts. Family resting places, their presence within the city plan tells us something. The living and those who came before shared the same space. This wasn't a settlement of strangers. It was a place of deep roots where generations were connected to the land and to each other in life and in memory. All of this, the homes, the workshops, the tombs, paints a picture of a stable, organized society. A small but thriving node in the Bronze Age world. Then the sea took the blueprint. The cause of the submergence is a textbook example. The region is seismically active. Earthquakes are common. Research suggests a series of powerful quakes over centuries caused the land to subside, to sink. This geological vulnerability was compounded by the global rise in sea levels after the last ice age. It was a 1-2 punch. The ground likely dropped during a seismic event, and the ocean, which was already slowly climbing, rushed in to claim the new low ground. This might not have been a single catastrophic wave. It could have been slower, played out over generations. A quake would damage buildings and lower the land. The sea would advance, the community would rebuild a little farther back, but each seismic event reset the clock, each time giving the sea a little more advantage, until the fight was no longer sustainable. What makes Pavlopetri so hauntingly informative is its completeness. We aren't looking at a monument or a lone temple. We're looking at the entire fabric of a community. Its homes, its industry, its sacred spaces, all preserved in situ. It shows us not just how a city drowned, but what exactly was lost. It makes the abstraction of collapse painfully specific. It was the smell of bread from a particular courtyard, the sound of a loom in a certain room, the memory of ancestors honored in a specific tomb. The sea didn't just swallow stones. It swallowed the accumulated rhythm of thousands of daily lives. This silent grid on the seafloor is a fossilized moment, a perfect, eerie microcosm. It asks us to consider what else, in the vast archive of sunken coasts, holds the quiet details of a world we can only piece together from the fragments. The blueprint of a city is one story, the blueprint of the sky is another, and we can read that one now in a place you wouldn't expect, a coastal marsh. Quiet, still, a researcher pushes a hollow tube down into the peat. They pull up a long core of earth. Laid out on a table, it looks like a layered cake. Dark mud from centuries of plants decaying, but then an interruption, a thin, pale band of coarse sand, then more mud, then another sand layer and another. That sand isn't natural to the marsh. It's sand from a beach or a dune carried far inland by a huge force. Each sandy stripe is a geological signature. The mark of an ancient hurricane, a violent visitor from a forgotten season. This is paleotempestology, the science of reading past storms. Researchers don't just look at marshes. They study coral skeletons. As a coral grows, it records the temperature and conditions of the sea. A sudden spike in certain elements can mean a massive influx of freshwater from hurricane rains. They examine coastal ponds where a storm surge would have washed over the land, leaving behind a distinct layer, shells and marine sediment. They even analyze the shape of coastal barriers and sand ridges, which can be sculpted by the power of repeated storms. By putting these clues together, scientists can build a timeline, a history of hurricane activity going back thousands of years, and what they find aren't random events. They find clear patterns, periods of relative calm, and then distinct eras of hyperactivity, centuries where powerful cyclones or hurricanes struck certain coastlines with a frightening frequency. For an ancient coastal megacity, this changes everything. A single catastrophic storm is a tragedy you can recover from, but an era of hyperactive storms is a death sentence. It's a relentless, demoralizing assault. Imagine the cycle. A massive cyclone makes landfall. Its storm surge, a wall of water pushed by the winds, crashes over seawalls. It floods the lower city. It scours the harbor, sinking ships and smashing docks. Saltwater poisons the fields. The community spends years rebuilding. Draining resources, repairing. Just as life returns to normal, another storm hits, maybe even stronger, then another. The frequency itself becomes the weapon. Each storm erodes not just the land, but the society's capacity to respond. Its economic reserves get depleted. Its labor force gets exhausted. The political will to keep rebuilding a city in such a dangerous place begins to falter. Evidence is mounting that these climate regime shifts coincided with the decline of several coastal societies. Studies of sediment cores from the Gulf of Mexico suggest periods of intense hurricane activity. Around 3,500 years ago, and again around 1,000 years ago, these windows of time overlap with archaeological evidence for cultural transitions and site abandonments along vulnerable coastlines in that region. It paints a picture, a world becoming suddenly, violently hostile to settlements built at the water's edge. The cities weren't necessarily drowned in one event. They were pounded into submission, their harbors, the source of their wealth, rendered unusable by silt and wreckage, their fleets destroyed, their agricultural base repeatedly salted and ruined. The choice eventually became stark and simple: leave or face annihilation. This adds a crucial layer to the collapse dynamic, an atmospheric layer. It wasn't just the ground sinking or a lone tsunami striking. It was the very climate of the coast turning against human habitation. The weather patterns shifted into a mode that delivered catastrophe on a schedule. This turns the narrative from a single geological accident to a prolonged environmental siege. The people living through it would have seen their world become unrecognizable. The sea they relied upon, the source of food and trade, transformed into a recurring monster. Their myths would speak of gods of wind and water grown wrathful. Their oral histories would tell of a time when the storms never stopped coming, and eventually they would gather what they could and move inland, leaving their stone foundations to be buried by sand. Not from one storm, but from the accumulated fury of an angry age. The quiet marsh core with its striped layers holds the proof. It's the archive of the sky's fury, written in mud and sand, telling us why sometimes a city doesn't just fall, it is slowly, decisively washed away. A modern evacuation order comes through phones, through sirens. Roads get cleared, shelters open, people move with a shared sense of the threat. It's a logistical ballet, all science and planning. Now put that same threat in an ancient coastal city. No satellites, no weather models, just the sky turning a strange green, the sea pulling back to a frightening distance, or the slow creep of salt into the wells. The disaster isn't just physical, it's a crisis of understanding, and in that uncertainty, the city's fate moves from the hands of the gods to the hands of its people. The social fabric becomes the final defense. The rigid structure of many ancient civilizations gave order in stable times, but in crisis it could be a fatal flaw. A top-down hierarchy where everything flows from a king or a priestly class is slow to adapt. If the ruling elite see a series of storms as divine displeasure, the response might be to double down on ritual. Build a grander temple, not a taller seawall. Offer more sacrifices instead of organizing a relocation. Resources that could go to practical adaptation, stockpiling food, building flood barriers, scouting new sites get spent on appeasing the heavens. It's a tragic misallocation, a worldview that sees the crisis as a spiritual problem with a ceremonial solution. We can imagine a darker scenario, where fear and scarcity fracture the community. As food runs out and the waters rise, a desperate elite might hoard what's left inside the palace walls. They secure their own survival at the cost of everyone else. In that strained atmosphere, leaders might look for a scapegoat, blame a minority group or newcomers for angering the gods. This internal division, neighbor turning on neighbor, saps a society's strength faster than any storm. The energy for collective survival gets wasted on conflict. The city doesn't just face the sea, it collapses from within, consumed by suspicion, but the ruins also whisper of other possibilities. Not every society responded with rigidity or blame. Some must have shown real social resilience. Imagine a community where decision-making was more collaborative, where elders, farmers, sailors, builders could share what they knew. The sailor knows the sea's moods are changing. The farmer sees the soil failing. The builder understands which slopes are safest. Together, they piece together a pattern long before an isolated ruler in a palace could. That kind of society could make difficult choices. They might decide to gradually abandon the lowest neighborhoods, move vital functions to higher ground, organize labor not for monuments but for drainage canals, for reinforcing seawalls with communal effort. Their greatest adaptation might have been the decision to leave entirely, a managed, organized migration carrying their shared identity with them, so the physical ruins aren't just water meeting stone. They're the fossilized outcome of a social process. A crumbled wall might be where a public work failed, suggesting a loss of communal will. An orderly layout on a hillside might hint at a planned, phased retreat. The absence of portable goods in a sunken district could mean people had time to gather their things and leave. The presence of those goods might mean a sudden catastrophe, or a social breakdown so complete that looting came before the final wave. This reframes the whole narrative of collapse. It moves beyond simple environmental determinism. The sea level rose, the storms came, the earthquake shook. Those were the pressures. But the breaking point was human. It was determined by the flexibility of institutions, the equity of resource distribution, the capacity for collective action. A resilient society could bend, adapt, transform under pressure, leave behind a changed but continuous culture. A brittle society, locked in rigid thought and unequal structure, would shatter. The sunken city is a monument to a moment of ultimate test. It holds the answer to a question. When the world changed unimaginably, did the people inside its walls see each other as partners in survival or as rivals for a vanishing future? The silent stones have much to say about the human heart. The ground can just disappear, you're standing on it, and then it's not there. We see it now on video. An earthquake hits and a street drops, a piece of coastline just falls. That's co-seismic subsidence. The water isn't rising, the land is falling. In places like the Pacific Rim or around the Mediterranean, this was a hidden threat for any town by the sea. A big quake could lower the shore by meters in minutes, and the ocean would come in, not as a wave but to stay, a permanent flood. The city's foundation becomes its grave. It leaves a specific mark in the archaeology. A tsunami scours and leaves debris. Subsidence is different. Things stay more intact, they just go deeper. They sink where they stand. Take Baiae, the Roman resort on the Bay of Naples. It was where emperors and senators went for luxury, famous villas, thermal baths. Now you can snorkel there, over marble floors, columns and statues standing upright in clear, shallow water. The cause is a mix, volcanism and seismicity. The region is on a volcanic field. Magma chambers underground fill and empty. The land above inflates, deflates like a giant breathing, and then earthquakes on local faults. Together, it led to a sinking, gradual but decisive. Parts of Baiae's coast just dropped. Its wealthy districts flooded for good. The ruins aren't shattered. They're preserved, a sunken garden party, frozen. This explains a particular puzzle. why some ruins are in deep water but so close to the modern shore. A slow sea level rise would make a gentle slope, but a city found at a sudden drop-off, its harbor walls too deep for ancient docks, that points to this. The earth opened up and it could be fast. Survivors would have seen their world recede, the sea claiming streets, buildings, like the land was being swallowed. It's inescapable. You can't outrun the ground collapsing. It adds another layer of vulnerability. A society could have the best seawalls, the best drainage, perfect knowledge of storms. But if the continent itself decides to shift, to settle, to sink, all that human ingenuity becomes irrelevant. The ruins of Baiae and places like it, they're monuments to a more unsettling truth. They tell us that sometimes the stage itself can just dissolve. The mud keeps a kind of calendar. When you dig at a place on the coast, you're not just looking for things people left behind. You're reading the ground. Each layer tells you something, and what it says is that a city didn't usually end all at once. It was a story of things happening again and again. You look at the side of a trench. At the very bottom there's hard packed earth. That was a street. Then suddenly a thick line of sand full of seashells. Broken pottery mixed in. That's a tsunami, the first one. So the people who lived there, they clean it up, they rebuild. The next layer shows that new floors, new foundations, life comes back. But then there's another line, a different one. This time it might be a layer of fine ash from a volcano far away. It blows in and covers everything. It gets in the fields, in the water, and they get through that too. They sweep the ash away, they plant again. But each time something happens, the city has a little less to work with. The people are more tired, the whole system is more strained. And then at the very top of all these layers, you see the last one. It's not more wreckage. It's something quieter. It's silt, fine mud from the sea. It just settles over everything. It fills in the gaps between the last stones that were ever put there. That sequence tells you the story. It wasn't one disaster, it was several. A tsunami, then a volcano that made things cold and dark, then maybe a time of bad storms. Each one left a mark in the mud. The city is like a body getting sick over and over. It might get better after the first sickness, even the second, but the damage adds up. It can't heal anymore. The money, the food, it's all gone. There are fewer people. Everyone is just worn down by all the trouble. So when the last change comes, maybe one more huge storm or the sea just rising past a certain point, there's nothing left to fight it with. The city doesn't disappear in a day. It fades over years, a lot of terrible years. Each one leaves a darker stain in the soil than the one before. This evidence, these layers, they change the question. You stop looking for one thing that caused it. You see collapse as a process, a slow coming apart, a complex thing under too many pressures all at once. The ruins aren't a picture of a single moment. They're the last page, the end of a very long, very hard story. The mud layers tell a story of exhaustion. But then there are ruins that start a different argument. It's about what a ruin even is. Off the western tip of Japan, near Yonaguni Island, divers go down to a place that shouldn't be there. They call it the Yonaguni Monument. It's this huge stone structure rising from the seafloor. You see these massive, flat terraces, sharp corners, perfect right angles. Things that look like wide staircases, edges cut straight. There are pillars, a triangular opening that seems too exact. From some views, it looks just like a sunken plaza. A ceremonial center carved right from the bedrock. The scale is immense. It feels architectural. It feels planned. This find started a firestorm. Could this be a lost civilization? A Pacific Atlantis swallowed by the sea thousands of years back? Or is it just a stunning natural formation? The experts split into two camps. On one side, the geologists. They point to the rock. It's sandstone. Sandstone naturally fractures along straight lines, creating planes and joints. They say powerful underwater currents over thousands of years can erode along those fractures. That can make flat surfaces, sharp edges, even steps. They call it sheet jointing and differential erosion. Those strong currents in the channel, they argue, did the sculpting. The features, while incredibly geometric, are a magnificent accident. They see a complex rock formation, not a plaza. On the other side are marine archaeologists and some researchers. They see clues that go beyond nature. They highlight features that seem to defy simple erosion. They point to what look like tool marks on some surfaces. They note what appear to be carved symbols, though that's heavily disputed. What's most compelling to them is the arrangement. The monument isn't just one odd shape. It's a collection of seemingly connected structures, terraces leading to platforms, what looks like a processional road, a star-shaped basin. This apparent layout, this sense of a planned complex, is harder to chalk up to random currents. Whether you lean natural or artificial, Yonaguni does something. It forces a question about our own assumptions. What does a ruin actually look like? We expect cut stones, pottery, clear tool signs. But if a civilization worked directly on the living bedrock, shaping it in place, how would we tell their work from the Earth's work? Especially after 10,000 years of waves and currents, the line between geology and human history gets blurred, beautifully, frustratingly blurred. This is the core challenge of underwater archaeology in its most dramatic form. On a site like Pavlopetri, the street grid speaks for itself. At Yonaguni, the stones whisper in a language we're still learning. It reminds us the planet can create forms of breathtaking regularity that mimic human design. And it reminds us our ancient past might hold civilizations whose architectural signatures we don't yet recognize. The monument, in its silent ambiguity, is a lesson in humility. It asks us to look deeper, to question our categories, to accept that some mysteries resist easy answers, holding their secrets tight beneath the shifting sea. A city's story doesn't end when the streets finally flood. It goes with the people who left, survivors carrying a whole world that's gone under. They took what they could carry. Tools, food, but also the things you can't hold, the sound of the waves, the way the market was laid out, what the sailors knew, what the masons knew. Their fear and whatever hope they had left, that movement of people is the next chapter, the one we don't always see. A coastal city collapsing, that's an ending locally. But it can be the start of something else across a whole region. Imagine a group arriving at the gates of an inland kingdom. They're exhausted. Their group has grown, pulling in people from other drowned towns. They tell stories about an angry sea swallowing stone walls. To the farmers who have always lived inland, these stories sound like madness or like a curse. The newcomers need land, they need water, the resources are limited, tensions build, and then they break. You see this in old records from times when the climate broke down. Like at the end of the late Bronze Age, the records talk about sea peoples attacking empires. Where they came from is debated, but many scholars think they weren't just pirates. They were displaced people, complex societies along the coast coming apart, pushing skilled, desperate fighters inland looking for a new home. Their migrations weren't peaceful. They were often the spark for conflict, for old kingdoms to fall, for new ones to be born in a painful way, but they carried something else too. Seeds of innovation. A refugee from a sophisticated port city might know advanced metalworking. Another might understand navigation by the stars or how to build a cistern. That knowledge arriving in a new place could act as a catalyst. So when archaeologists see new pottery styles, new building methods, new social structures appearing suddenly in an inland region, that might not be random change. It could be the direct imprint of a displaced, knowledgeable population moving in or taking over. They didn't just bring conflict, they could found new states. Blending their old coastal identity with the new reality. The Philistine cities that appeared after the Bronze Age collapse, for example, they show a distinct material culture, different from before, suggesting a new people settling there, possibly from elsewhere in the Mediterranean. And then there was the memory, the cultural memory. The experience of catastrophic loss got woven into their identity. It became myth, it became ritual, a foundational story told around fires for generations. That memory shaped practical choices for centuries. A community that remembered the Great Flood would be wary. Deeply wary of settling too close to the shore again, they might choose hilltops or river valleys at a safe distance. That collective caution, born from trauma, would influence where people lived for generations. It might even create a gap in coastal development that archaeologists could find later. The myth was a survival guide, a warning encoded in a story. The sea holds an ultimate, unpredictable power. So the ruins aren't just endpoints, they're catalysts. The physical city sank, but its people, its ideas, its stories, they radiated outward, like ripples from a stone dropped in water. They changed the demographic map, the political map, they transferred technology, they embedded an ecological lesson into the cultural psyche. The drowned metropolis, in its fall, helped write the next chapters of human history. In lands far from the coast, its true legacy isn't what was lost under the waves, it's what was carried away from them, a simple clam shell. It's a kind of diary. Not of the clam's life, but of the water. In a lab, a researcher takes a tiny piece from a midden heap, an ancient garbage pile from a sunken city, and puts it in a machine. They're not dating it, they're reading its chemistry. The ratio of oxygen atoms locked in the shell's crystal structure, that's geochemical analysis. It translates stone and shell into a story of ecological betrayal. When that clam was alive, filtering water in an estuary or a freshwater spring near the city, it absorbed oxygen from the water into its shell. The isotopic signature of that oxygen depends on one thing: whether the water was fresh or salty. Fresh water from rain and rivers has a lighter fingerprint. Seawater has a heavier one. As the clam grows layer by microscopic layer, it records this signature, a lifelong logbook of the water's chemistry. By drilling a tiny sample along the shell's growth lines, from its youth to its final day, scientists can reconstruct a history. They can see if the clam lived its whole life in a steady, brackish mix, or if, at a specific point, the isotopic ratio shifted dramatically, became much heavier. That shift is the smoking gun. It marks the precise moment saltwater invaded that freshwater source. This data is powerful because it operates independently of human activity. Pottery styles change, buildings get rebuilt, but the chemistry of the water is an impartial witness. It doesn't lie. A collection of shells from different layers of a midden heap can create a high-resolution timeline. It can show exactly when and how quickly the local environment turned saline. Imagine what this reveals about a city's final century. The earliest shells from the heap show a stable, slightly brackish signature. Perfect for a healthy estuary that provided fish and fresh water. Then, in shells from a layer dated a few generations later, the signature begins to waver. The heavy seawater signal becomes more pronounced year by year. This is the slow creep, the gradual poisoning of the aquifer, the salinization of the irrigation canals. The city's lifeblood is being contaminated. Farmers struggle. The community spends more energy to find clean water. Then, in the very last layer of shells, those from the final years of occupation, the data might show one of two things. A sudden, catastrophic spike to a fully marine signature would point to a single, violent inundation. A tsunami surging inland, not just flooding streets but permanently altering the water table in an instant. Or the data might show that the shift to full salinity happened after the layer containing the last human artifacts. That tells a subtler story. It suggests the people finally left, driven out by other pressures, and then the sea fully claimed the land. The ecological disaster was the cause, not just the effect, of the abandonment. This geochemical clue helps untangle the complex knot of collapse. It separates a gradual, grinding environmental stressor from a sudden, catastrophic event. It reveals the slow-motion crisis that weakens a society from within. The story is no longer just about walls falling. It's about the last drink from a well that once tasted pure, now carrying the salt of the sea. It's about the quiet, chemical suffocation of a place, written in the forgotten shells of its last meals. The final layer of silt has its own quiet story. But to read it, you have to understand the silence, the difference between a city that drowned and one that was just left behind. It's in the smallest details. It's a crucial distinction. It separates a sudden catastrophe from a managed retreat. Evidence of a violent, unexpected end is often stark, heartbreaking. Researchers look for what they call in situ remains. That's Latin for in position. Things found exactly where they were when the disaster hit. The most telling sign is human remains within the ruins. People who didn't have time to flee. We have to discuss this with respect, but it's a clear stopwatch, a tragedy that unfolded too fast for escape. Other signs, valuable items left in plain sight. Jewelry on a floor, a stash of coins by a doorway, tools scattered in a workshop like they were dropped. There might be evidence of widespread fire. Or structural damage showing a single directional force, walls all pushed over the same way. These are the fingerprints of an instant, a tsunami, an earthquake. A sudden flood. The city's daily life was interrupted mid-sentence and sealed under water or sediment. An orderly abandonment leaves a very different signature. That story is one of preparation and choice. Archaeologists find sealed storage rooms, maybe non-perishable goods left behind as an offering or for a hoped-for return. But the true valuables, precious metals, heirloom weapons, portable wealth, those are gone. There's a systematic lack of human remains that suggests the community had time. Time to honor their resting places or carry their ancestors with them. Buildings might show signs of deliberate dismantling, useful timber or roofing materials removed. The settlement isn't shattered, it's emptied. It feels like a house whose owners moved out, taking their most cherished things, not one destroyed by a storm. Applying this lens changes how we see specific sites. Take Atlet Yam, a Neolithic village submerged off the coast of Israel, found under the Mediterranean. It has stone houses, wells, even a stone circle. But crucially, researchers haven't found evidence of a sudden, violent end. No signs of catastrophic structural collapse from a wave. Instead, the site suggests a gradual response to a creeping threat. The rising sea level after the last ice age likely made the freshwater wells brackish, salinized the soil. Facing a slow-motion environmental change, the community likely made a collective decision. They gathered their tools, their seeds, their knowledge, and moved inland to more sustainable ground. Atlet Yam represents not a tragedy but an adaptation, a graceful, planned withdrawal in the face of a changing world. Understanding this spectrum, from instantaneous catastrophe to managed abandonment, it's vital. It rescues these ancient people from being mere victims of fate. It reveals their agency. It shows human responses to environmental pressure were diverse, ranging from desperate flight to calculated migration. Some societies were caught by surprise and swallowed whole. Others saw the waters coming. They read the signs in their failing crops and salty wells and chose a different path. They carried their civilization with them, ensuring its continuity elsewhere. The ruins, therefore, aren't just monuments to disaster. They're also testaments to foresight, to difficult choices, and to the enduring human instinct to survive, even if it means leaving home behind. That slow chemical suffocation of a place, it has a modern echo. You look at a satellite view of Mumbai or Shanghai or Miami, glittering towers, dense networks of light. These coastal megacities, they're built on the same logic as Pavlopetri or Dwarka, the logic of the harbor, the trade route, the economic engine right at the water's edge. They're triumphs of human engineering, just like those ancient ports were, and they face the same four ancient threats, but now accelerating. The sea is rising. Not from post-glacial rebound, but from thermal expansion and melting ice. The ground is subsiding, not just from tectonic shifts, but from the sheer weight of the cities themselves, and from pumping groundwater, which makes the land compact. Saltwater is creeping into the aquifers that supply drinking water to millions, and the storms, fueled by warmer oceans, are growing more intense, delivering catastrophic surges with greater frequency. So these sunken ruins aren't just archaeological sites anymore. They've become empirical evidence, a controlled experiment run by history, showing the inevitable outcome when environmental pressures overwhelm a society's design. They are the control group, and our modern cities are the test group, operating under strikingly similar conditions. The ancient world didn't have climate models. It had experience, and its experience, written in stone and sediment, is clear. A society that builds its greatest achievements on a fragile, dynamic coastline, it's making a wager with planetary forces. This changes the study of these lost cities. It turns it from a historical curiosity into a critical diagnostic tool. It lets us see collapse not as a mysterious event, but as a process. A process we can now observe in its early stages. We can measure our own relative sea level rise. We can map our own subsidence with satellite radar. We can test our own wells for saltwater intrusion. We are collecting the same data points that, in the ruins, we find in the final layers. The urgency comes from the scale. Ancient Ugarit or Pavlopetri housed thousands. Our coastal megacities are home to tens of millions. The economic circuits they anchor are global, hyper-connected, and fragile. A major disruption to the port of Shanghai or Rotterdam wouldn't just flood a city. It would trigger supply chain failures that ripple across the world economy within days. That interconnectedness that was a vulnerability in the late Bronze Age is now a planetary risk. So the lesson of the submerged ruins isn't one of doom, but of clarity. They show us the destination of the path we're on. If we rely solely on static defenses and reactive measures, they underscore that the most costly adaptation is the one that comes too late. The ancient societies often failed because their worldview or their political structure couldn't conceive of the scale of the change, or couldn't muster the collective will to act until it was irrevocable. We have no such excuse. We have the science, we have the precedent. These sunken archives are a library of past futures, and they're open for us to read. The question they pose isn't academic anymore. It's the most practical one we face. Will we see the pattern in time? The water that drowns a city can also keep its secrets. Perfectly frozen, it's a preservation paradox. On land, things rot. Wood, cloth, leather. They're consumed by microbes because there's oxygen. But in deep water, under silt or mud, the oxygen can't reach. An anaerobic environment forms, a timeless vault. So the force that ends a civilization becomes its archivist. A wooden ship's hull, which would turn to dust on land, can lie on the seabed for 3,000 years. Its planks and joinery intact. A basket woven from reeds might still hold its shape. Even the most delicate things survive. At a sunken Neolithic village, they found fishnets. Knotted fiber, perfectly preserved, and that tells you not just that they fished, but how they made their tools. They found stores of grain, fruit pits, animal bones with cut marks, a direct menu from a lost world. That level of detail changes everything. It moves you from studying monuments to understanding minutes. You don't just know they built temples, you know what they ate for lunch on the day the water came. But this preservation has a trade-off, a cruel one. While the mud protects fragile organics, the marine environment works on everything else. Stone foundations so permanent on land get scoured by currents. Pitted by saltwater, tumbled by storm surges, a temple wall that stood for centuries can become a scattered line of rubble, its original form a puzzle. Heavy artifacts like stone anchors might stay put, but lighter things, pottery shards, coins, small tools get carried away by the water. They settle far from where they were used. It creates a confusing map, so the record is skewed, strangely skewed. You might have a beautifully preserved wooden comb, the teeth still distinct, but you've lost the entire house it was kept in. You can analyze the last meal in a cooking pot, but you can't see the kitchen it was cooked in. That's the bias. The underwater archive preserves the intimate and the ephemeral with stunning clarity, while it erases the grand and the architectural. To listen to these ruins truthfully, you have to understand that paradox. It reminds you the picture is never complete. It's a collage, assembled from what survived a double filter, catastrophe and time. The stone temple, though ruined, shouts its presence. The discarded fishing net whispers. The challenge is to hear both voices and to recognize the silence between them. You can't let the wonderfully preserved object distract you from the profound absence beside it. A single, intact merchant ship on the seafloor tells a rich story of trade and technology. But it can't tell you about the bustling harbor district that built it if that district is gone, swept away. The archive is fragmentary by nature. It offers glimpses of breathtaking intimacy, framed by vast chambers of forgetting. That doesn't diminish its value, it defines its truth. The story of these cities is told in both the objects that endured and the empty spaces where other objects should be. To read this sunken record is to practice a kind of humility, piecing together a vibrant world from the whispers the sea chose for its own reasons not to erase. The hum of a multi-beam sonar is a quiet sound. A ghostly grid appears on a monitor. It's not a picture of light, it's a picture of sound, a map of a drowned city, painted by millions of acoustic pings coming back from the dark. This is a new age of discovery. For centuries, these ruins were found by chance, a fisherman's net catching on stone, a diver seeing something in clear, shallow water. But now we're not limited by human sight or by human endurance. We send out machines to see for us. It started with sonar, side-scan sonar. It's towed behind a ship, sending out fan-shaped pulses of sound to either side. The echoes come back and create an image of the seafloor, almost like a photograph. It can tell the difference between sand and rock and a man-made wall. It lets archaeologists survey huge areas. They can scan the equivalent of entire counties, looking for something that doesn't belong. Then came the robots. Remotely operated vehicles, ROV, they're unmanned submersibles connected to a ship by a cable. They carry high-definition cameras, powerful lights. Robotic arms, they can hover in a strong current, completely still, and film a delicate artifact for hours. Or they can brush away sediment with a gentle jet of water. They go where it's too deep for a diver, or too dangerous, or simply where it would take too much time. For the broadest searches, we use autonomous underwater vehicles. Oh, these are robotic explorers. They follow a pre-programmed route, flying over the seabed like underwater drones. They map vast swaths of ocean with sonar and sensors. They work around the clock in any weather. They build a foundational map of the deep, but maybe the most transformative tool is one that brings it back to a human scale. Photogrammetry, here's how it works. A diver or an ROV takes thousands of overlapping photographs, high resolution from every possible angle, then software analyzes the images. It matches common points between them. It calculates the precise 3D position of every point it sees. The result is a digital model, hyper-detailed, measurable. You can fly through the streets of a sunken city. You can take measurements between walls with millimeter accuracy. You can study the tool marks on a stone block from your desk on the other side of the world. It's non-invasive archaeology. It preserves the site exactly as it was found, a perfect digital record made before any physical work begins. These technologies aren't just tools. They're translators. They're converting the silent language of the deep into data. Data we can see, data we can measure and understand. A mysterious sonar return becomes a mapped city block. A dark shape in a video frame becomes a photorealistic model of a shipwreck. The acceleration is staggering. Discoveries that once took a lifetime of diving and luck can now be pursued systematically. Documented in a single research season, we're moving from an era of anecdote to an era of evidence. Each newly mapped ruin is another data point. It adds to our understanding of ancient coastal life. And its vulnerabilities. We're not just finding lost cities anymore. We're beginning to see the patterns that connect them, the shared signatures of a geological fate written across the drowned edges of continents. The machines show us the bones, but it's still up to us to listen for the story. That final moment on the seafloor, it's a snapshot, but it's a snapshot of an equation. A lot of variables all interacting. To understand it, you have to step back from the individual clues, the seawall, the salt in the shell, the flood myth. You have to weave them together into one story of collapse, the story of how a coastal city falls. So you imagine a port at its peak, ships crowding the harbor, bringing in copper, tin, olive oil, ideas from distant lands. Its wealth is built on that connection to the sea. The streets are loud, granaries are full. Temples rise up for generations. Life is good. That's the stable baseline, but underneath that, slow pressures start to build. The first is environmental. Global sea level creeping up, maybe an inch per generation, almost imperceptible, but it means the spring tides reach a little farther every year. Saltwater starts seeping into the freshwater under the city. Farmers notice their crops don't yield as well. The soil tastes different. They have to dig new wells farther inland. That's the gradual stressor. It weakens the foundation, literally. Resources that once went into trade or art now go into adaptation, into holding back the creep, and at the same time, social pressures mount. Maybe the ruling class, safe in their hilltop palaces, hoards the dwindling grain. Maybe they insist the proper response is more sacrifices, not better canals. Inequality strains the social fabric. Trust between people and their leaders starts to fray. The community's ability to act as one, to mount a collective defense, is compromised. The society becomes more brittle, even as the environmental pressure increases. Then comes the catalyst, the trigger. It might be geological, a massive undersea earthquake. The ground shakes violently, causing co-seismic subsidence. A whole section of coastline drops a meter in minutes, and then the tsunami arrives, a wall of water, silent at first, then roaring. It smashes over the seawalls. It scours the lower city. It deposits that thick layer of marine sand over everything. Or the catalyst could be climatic, an era of hyperactive storms. A succession of powerful cyclones, each with a devastating storm surge, batter the city every few years. Each one costs more to recover from than the last. The catalyst is the point of no return. It shatters the already strained system. The economic networks go first. The harbor is destroyed, silted with wreckage. The merchant fleets are at the bottom of the sea. Trade, the city's lifeblood, stops. The web that brought tin from Afghanistan and grain from Egypt snaps. Suddenly the city is isolated and hungry. With trade gone and the fields salted by the surge, agriculture fails. The food supply collapses. Scarcity breeds desperation. The weakened social order crumbles. What little trust remained evaporates. It's every family for itself. The leadership, if it still exists, loses all legitimacy. There's no collective plan, only individual survival. This is when the exodus begins. The survivors, those who can, gather what they can carry. They flee inland. They become refugees. They carry with them the trauma of the disaster, the story of the angry sea that swallowed their home. That story, told and retold over campfires for generations, becomes myth. It gets embellished, but at its core, it's a memory of a real collapse. Behind them, they leave the city, not as a ruin yet, but as an abandoned shell. For a time, it sits empty. Then, slowly, the sea completes its work. The slow, global rise continues. Storms erode the unprotected walls. Silt fills the streets. Marine life colonizes the stones. The city is gradually, completely claimed by the water. Its final state, the one we find millennia later with sonar, is that frozen moment. A snapshot of a multi-stage disaster. This model changes things. It shows collapse is rarely a single event. It's a process, a tragic interaction between a changing environment and a vulnerable society. The environment provides the pressure, the rising sea, the salting earth. The society provides the vulnerability, its inequality, its rigidity, its dependence on one economic model. The catalyst is the match, but the tinder has to be dry. The ruins aren't just what the water did. They're the physical record of that interaction, a record of a world that could no longer hold. These silent stone sentinels have a lesson. It echoes up through the water across centuries. These aren't just sunken curiosities, they're archives. They hold the record of human ambition, communities reaching for greatness right at the water's edge. You see brilliant adaptation there, seawalls, cisterns, a stubborn fight against the inevitable, and they reveal our vulnerability, our ultimate vulnerability to the raw, shifting forces of the planet itself. We've walked their drowned streets. We've seen how it happened. It wasn't one cause. It was a perfect storm, geological shifts that lowered the land. Climatic changes turning the weather fierce, the seas higher. Social pressures making societies brittle just when they needed to be resilient. These forces conspired. And greatness was erased from the map. But these stories aren't just history anymore. They're parables for our present. Look at our own glittering coastlines now. The megacities there face similar threats. The seas are rising again, this time from our own actions. The ground is subsiding in many places, under concrete, from drained aquifers. Saltwater is creeping into the drinking water for millions, and the storms, supercharged by a warmer ocean, deliver catastrophic surges, terrifying power. The ancient pattern is repeating, but on a scale those old civilizations couldn't have imagined. The lesson isn't inevitable doom, it's necessary wisdom. These ruins remind us civilization isn't a conquest over nature, it's a partnership, a delicate, ongoing negotiation with the planet that sustains us. That partnership requires respect for the power of the elements. It demands foresight, the willingness to read the signs, in the changing chemistry of a shell, in the creeping high tide line. To act before the crisis is at the gate, and above all, it calls for humility. The humility to understand our greatest engineering triumphs are temporary. Temporary bulwarks against a dynamic, living earth. If these stones could speak, their message would be simple. They'd tell us to heed the rising tide. Not with fear, but with clarity and courage, to build our future not in defiance of the water's edge, but in harmony with its enduring truth. These sunken archives are a gift from the deep. A chance to learn from a past we can now clearly see, so we might navigate a future we are still trying to shape.